Alright, so just a little recap of what we did in class today. And we started off by trying to use our intuition to come up with the rule for how to anti-differentiate something that is a polynomial term, or an expression containing multiple polynomial terms. So here we got the derivative of a function is 3x squared plus 4x plus 2. And the question or the task that you were set was to try and find an expression for the original function. Now we've got the answer there, but how did I come up with that is what we're really after here. So if I know that here's a function I want to find the derivative of, and the derivative ends up being 3x squared plus 4x plus 2. So we know from our general rule, so let's just do this in a different colour over here. Our general rule, or our power rule, we've also called it, is if a function is something times x to the power of n, then its derivative is found by first multiplying by that power, so it'll be n times a, then it's x, and then the power gets decreased by 1. And that's the key to figuring out how to go backwards. So here, our first term here is 3x squared. It must have come from an expression that contained x cubed. Now we just check, what is the derivative of x cubed? Well, I'd multiply by 3x squared. Oh, that would actually give 3x squared as a derivative. So x cubed's all I need. Let's have a look at 4x. It must have come from something which had a power of 2, some sort of x squared term. Now if I did the derivative of x squared, I'd end up with 2x. If I need 4x, I must have had a 2 there to begin with. Now when I do the derivative, 2 times 2 would give me 4, and I'd end up with 4x. Finally, this 2, how does a constant come about? Remember that 2 corresponds to 2x to the power of 0. So it must have come from 2x, which obviously has a power of 1. Check the derivative of 2x. Yep. Multiply 1 by 2, I'd get 2, and the x to the 0, which we don't actually need to write, would be there. The only other thing we need to consider is that this function could have had any constant added to it, and the derivative would still be the same, 3x squared plus 4x plus 2. It doesn't matter if it's got a number added to the end, doesn't matter what that number is. The derivative would always go to 3x squared plus 4x plus 2. So that's the process that we started off looking at and trying to come up with it intuitively. The rule that we now use, because we know the rule, if I can find where my, oh, there I am, I'm way down there, is if f dash of x, so if the derivative of a term is equal to ax to the n, then f of x, so the parent function, the function that ax to the n is the derivative of, you add 1 to the power, so it's going to be ax to the n plus 1, and then divide by the new power. And then we just add our constant of integration at the end. If you do the derivative there, you're going to see n plus 1 is going to cancel, and I'll be left with ax to the power of n, which is what we wanted. I hope that helps. We can go over a lot more of them if we need to, and we'll see you later. Cheers.